Hey, welcome to the Explainer. Today, we're going to dig into a couple of PLC instructions that seem super simple on the surface, but are, and I mean this, the absolute bedrock of how we control machines. Let's get right into it.
So let's just start with a big question, the whole reason we're here. How do you give a machine a memory? How do you press a button once to start something and have the machine actually remember to keep it running long after you've walked away?
All right, to figure that out, we first need to wrap our heads around a really common hurdle in automation, something I like to call the doorbell problem.
Think about it. It's super simple. A doorbell is what we'd call momentary. It only rings as long as your finger is on that button, right? The second you let go, it stops. But a light switch, well, that's a whole different story. You flick it once, and it remembers. The light stays on. It holds that state until you decide to change it.
Okay, so let's translate that into PLC speak. A standard output instruction, you'll see it as an OTE, it acts just like that doorbell. The output is only on when the logic leading up to it is true. That's not great for, say, a motor that needs to keep spinning. For that, we need the light switch. And that, my friends, is exactly what latching logic is all about. So let's meet the first half of our dynamic duo. This is the output latch, or OTL. You can just think of this instruction as the turn it on and keep it on specialist. It's the one that flicks the switch on.
Now here is the magic word for today, retentive. The OTL is a retentive instruction, and that's absolutely crucial. It means once it sets a piece of memory, a bit, to high or a 1, it retains that state. It holds on tight, even if the logic that first turned it on isn't true anymore. It literally has a memory.
You have to understand, the OTL has one job and one job only. When its conditions are met, boom, it sets a bit to 1, and that bit stays 1. That's it. The really important thing to get here is that it can only turn a bit on. It has zero, absolutely no power to turn it off.
So you're probably thinking, okay, if the latch can only turn things on, how in the world do we stop anything? Well, that's where its partner comes into play. Let's meet the output on latch, or OTU. This is our dedicated turn-it-off specialist. And just like its sibling, the OTU is also retentive. Its whole purpose in life is to go find that exact same bit that was latched on and just flip it back to low or a 0. It's the off command, plain and simple.
And just like the OTL, the OTU is completely single-minded. When its wrong becomes true, it executes and it slams that bit to 0. And then, well, the bit stays off. See the perfect symmetry here? The OTU can only turn a bit off. It has no idea how to turn anything on.
So what we have is one instruction that only knows how to turn things on and another that only knows how to turn things off. These two aren't fighting each other. No, they're designed from the ground up to be a perfect team.
And here's the secret to their teamwork. The OTL and the OTU are always pointed at the exact same piece of memory, the same bit. One latches it on, the other unlatches it off. This elegant setup is how we finally solve our doorbell problem. We can now use a simple, momentary button to start something big, like a conveyor belt, and have it keep on running.
So here's how that whole dance plays out. An operator walks up and presses the start button. That makes the OTL's logic true, which latches the motor's bit on. The motor fires up and stays running. Then, whenever it's time, the operator hits stop. Now the OTU's logic becomes true, which unlatches that very same bit, setting it to off. The motor stops and it stays off. See? It's simple, it's clean, and it's incredibly powerful.
So let's step back for a second. What do we really do here? Because this is way bigger than just turning a motor on and off. We've actually given our control system a brand new fundamental superpower.
And this, right here, is the biggest takeaway of the whole thing. Using an OTL and an OTU isn't just some clever programming trick. It is, fundamentally, how we give a machine a memory. The ability to remember its own state. I am on or I am off. That's the essential building block for pretty much every complex thing we want to automate. And that really brings us to the final thought. Now that you know the secret, now that you know how machines can be taught to remember, it kind of opens up a whole new world of possibilities, doesn't it? So I'll leave you with this. What's the one thing you wish a machine in your life, whether it's at work or just an appliance in your kitchen, would remember to do for you after just one single command?